In this problem, we have a ladder and a house, and we're looking at how fast it's sliding down. So let's read the problem. A ladder 15 feet tall, so our ladder is 15 feet tall, leans against a vertical wall of a home. If the bottom of the ladder is pulled away at a rate, so here's a rate, 4 feet per second, how fast is the top of the ladder sliding down? So they're asking us about a rate. The wall when the bottom of the ladder is 9 feet from the wall. So we don't really have an equation here, but let's draw a diagram and we'll be able to see what's going on. We have a wall of a house, we have a ladder, and we have the ground. So the space between the top of the ladder and the ground can change, so let's call that Y. The ground, so when the ladder is moving out, this can change as well. Let's call that X. And the ladder, the length of the ladder is the ladder. It's not going to change. So that is a 15. So to write an equation that compares these three things, we use Pythagorean theorem. X squared plus Y squared is 15 squared. Okay. So here's our equation. Let's look at what we're given. We're given bottom of the ladder is pulled away, so that's the movement of x. So dx dt is 4 feet per second. And they have also told us that the bottom of the ladder is 9 feet away from the wall. So x is 9. And we need to find top of the ladder sliding down means the change this way. So we need to find dy dt. There's one piece of information that they've given us enough info to find, but they haven't explicitly stated it. What that is y. So we can figure out y from our equation before we take the derivative. X squared, we know x is 9, plus y squared equals 15 squared. So y squared is 225 minus 81. So y squared is 144, which means y is 12. Now that we have y, we have all the information we need. So now we're just taking the derivative and plugging in. So let's take the derivative. Derivative of x squared is 2x. Remember, our dx over dt plus 2y dy over dt equals 225, because we'll go ahead and write 15 squared as 225 since we know that's what it is. Now we plug in all of our knowns and find out what we need to. 2 times x is 9, dx dt is 4, plus 2 times y, we figured out was 12. dy dt is what we are figuring out, equals, and the derivative. Let's fix that. Silly me. The derivative of a number is 0. So that's a 0. As much as I like the number 225, that should not be in our problem. Sorry about that. So now we just evaluate and solve for dy dt. 2 times 4 is 8, times 9 is 72, plus 2 times 12 is 24, dy dt equals 0. So we'll subtract 72, 24 dy dt is negative 72. And then we will divide by 24, and dy dt is negative 72 divided by 24 is actually negative 3. That divides nicely. Don't forget your measurements. So we're looking at y. Y is the distance here. That is one-dimensional. So that means that we just need our measurement regular old feet per time, which is second. So we have feet per second. And there's our answer.